morning to all. So I am Dr. J.Immanuel, Assistant Professor, St.JOSEPH'S of Technology. So today we will see about the problems of Buckingham theorem. The previous video I explained to you about the procedure to how to arrive the Buckingham theorem. So what is the need? What are the types available to solve the problem you have seen. So this is for dimension analysis. We are going to solve based on Buckingham theorem. So dimension analysis based on Buckingham theorem. So in each all the process or any experiment, we have some kind of variable and independent parameters. If I want to increase my one objective, that is a dependent. To find out to get this dependent variable, we will have a lot of independent variables. So that is involved in the process. That's the independent parameters. So we will combine once you know all the things, we will arrange all the term, just we will find out what is the relation between each term. So we know the formula or dimensions for each term. So units we know, dimension we know. Once you know units for all the terms, you can find out what is the relation between these parameters, dependent and independent parameters, whether it is square of it or cube of it, or it is denominator or comes the numerator or terms in terms of constants. So like this we will see today. Okay, do the problem. So today we will see the problem. Resisting force of R of a supersonic plane during a flight can be considered as a dependent upon. Okay, so flight is flowing and flight experiences some resistance. Flight experiences some resistance. So the resistance of the flight depends upon what parameter? Length of the aircraft, velocity at which the aircraft moves v, and air viscosity, whether the air is denser or not denser, air viscosity or air density, and bulk modulus of air, that is change in volume by change in pressure to volume, that is bulk modulus of air K. So these are all the parameters that is observed during the flight flowing, supersonic flight flowing. These are the parameters observed. The question asked is express the functional relationship between these variables and the resisting force. Functional relationship between each things. So which is increasing, which is decreasing, which is square, which is cube. So which is in the right hand side, which is in the left hand side. And if we increase one parameter, which parameter will increase or decrease? These are the general observation I can make through dimension analysis. Before going to the exact terms of it is 25 times or 10 times, 3 times. So like this you can find out. Okay. So for example, you find out frictional coefficient is 4FL is equal to 2GD. So the 4 is a constant. So FL V square. So it is a V is in the square by GD. So GD will come in the denominator. These are all one relation. So kg per meter cube. Okay. So density, mass by volume. So we increase the mass, what will happen to the density? So that's what is the relation you are finding. Okay. So now you know how many parameters are here. First you write the parameters. So whenever getting the problem, first you write the parameters. Here the problem parameters are resisting force depends upon. So dependent parameter. So these are all independent: length, velocity, viscosity, density, and K, bulk modulus. These are all called dependent. Okay. So this is all the dependent. This is independent. You can change your length of the flight, you can change the velocity, you can slow down or faster. Okay. These are all these parameters also carry depends upon the place it moves. In one place, density of the air will be lesser. Another place, go 100 kilometers beyond, will be different. And bulk modulus. Okay. So the volume change in the volume also differ as a parameter. So function of length, velocity, viscosity, density, and bulk modulus. Okay. So based on working there, I can write R resisting force equal to F of L, V, mu, density, and K. So total you have 1, 2, 3, 4, 5, 6 parameters. So R is a dependent and remaining 5 are independent parameters. So this can be written as a function of R, L, V, mu, density, K equal to 0. You can write this equation as of 0. And now you can write n equal to 6. As from the problem you can find out total number of variables available 6. So that's called number of variables 6. That's what Buckingham theorem starts. Okay. N equals 6. Now your fundamental dimensions. Normally you have fundamental dimensions of 3. M, L, T in all the equations you have. This is a constant. In all the equations M equal to 3 only. So according to Buckingham theorem, if the equation contains n number of variables and having m fundamental dimensions, the 5 terms should be n minus m, 3. So that's what the definition of Buckingham theorem says. Okay, you can write m is obtained by writing the dimensions of variables R. So resistance is force, so mLT power minus 2. Okay, resistance is force, mLT power minus 2. Velocity is meter per second. So the previous video I explained about how to find the dimensions of this thing. If you have doubt, you refer to the previous videos also how to find out these dimensions for resistance. Force equal to mass into acceleration. Mass is m, acceleration is meter per second square. So mL t power minus 2. Velocity is meter per second. L by t, L t power minus 1. Viscosity is Newton meter per second square or kg per meter second. Kg is m, per meter second is L. So kg per meter second. So similarly, if you have density, so kg per meter cube. So kg is m per meter or minus 3. So k is, this is bulk modulus. So Newton per meter square. So Newton per meter square, you can write Newton is once again mass into acceleration per meter square. So if you combine this mLT power minus 2, that is this is Newton by meter square by L square. If you divide this equation by L square, you will get this. Okay, this is Newton per meter square. If you divide by L square, you will get this equation. M L power minus 1, T power minus 2. Okay. This is fundamental dimension problem was mLT and hence m equal to 3. So now you have found what is n equal to 3 and your m equal to 3, n equal to 6, m equal to 3. So like this you have found it from here. So you have to arrange your number of dimensions 5 times n minus m equal to 6 minus 3 equal to 6. Total of 6 n terms and normally m always 3. So n minus m will 3. Now you have to find out 3 5 terms. You have to arrange your equation to 3 5 terms. So 5 1, 5 2, 5 3. So you see how to arrange your 5 term. So 3 5 terms says 5 1, 5 2, 5 3 are found. So equation can be written as f1 equal to 5 1, f of 5 1, comma 5 2, comma 5 3 equal to 0. Okay. So here f1 of this term equal to 0. Here f1 of 5 1, 5 2, 5 3 equal to 0. Take it as equation 3. So the first term equation 1. So take this f1 equation 2 and take this equation 3. Okay. So now we have 3 equations. Now step 2, that's step 1. Step 2 you have to arrange each 5 term you have to arrange. Each 5 term should have 3 parameters. One should be geometric, next one be fluid, another one should be flow property. 3 variables should be there. So each 5 term should contain m plus 1. M is 3. 3 plus 1. Each 5 term should contain 4 variables. Okay. M is equal to 3. And also repeating variables. Out of 6 variables, 3 variables are selected as repeating variable. Out of 6 variable, 3 has to be selected repeating variable. R is a dependent variable, so you cannot choose, so it should not be selected. So remaining out of 5, I want to find out 3 parameters. Okay. One should be fluid, one should be geometric, one should be fluid, one should be flow property. Yeah. So normally we will see dimensions of L0. I will normally take L0 as a repeating variable. Okay. So this length, velocity, densities all are available in the problem. L0 is available. Now you can see all the 6 here. 1, 2, 3, 4, 5, 6. This is a dependent parameter here. These 3 are repeating variable. So total you have 6. 1, 2, 3, 4, 5, 6. Okay, total you have 6 repeating variable parameter. This is what you have to write. Okay. So the repeating variable order you chosen, you write L power A1, B power B1, rho power C1. Second equation L power E2, E power B2, and row power C2. Third equation L power A3, E power B3, row power C3 and one dependent variable, one independent variable. This is dependent, these are two independent. Now you can write like this. Now you have to balance both the sides one by one. Okay, take the first equation, second equation, third equation. Okay. We go to the first phi term. The first phi term. So write the first phi term here, guys. This is the first phi term. L is your meter. L is measured in meter. This is meter per second. L by T power minus 1. Density is kg per meter cube. M by L power minus 3. This is resistance, force, M by T power minus 2. Okay. So L by T1, L power T power minus 1. M L power kg per meter cube. M L power minus 3, M L T power minus 2. This is what I am going to write. This term I am going to write here like this. So you take the phi term is a dimensionless term. The phi 1 is called dimensionless term. I can write M0, L0, T0. Always you write phi 1, phi 2, phi 3 these terms. And you write the repeating variable here. L, V, rho, R. This is for L length, put L. V, meter per second, LT per minus 1 and density kg per meter cube. So this is M L per minus 3 and M L T per minus 2. Put A1, B1, C1 on the top. So multiply inside your L1, B1, each inside L power A1, L power B1, T power minus B1, M power C1, L power minus 3 C1. So M power 1, L power 1, T power minus 2. These are all terms arranged. Now equate the powers on both sides. Equate the powers on M, L, T. Yeah. So you can see on the other right hand side, this is left hand side. Here the right hand side M power is 0. You told the right hand side for the M the power is C1 is here. M for M power is C1 is given here. Here M power 1. Here M power C1, M power 1. So I can write here it is 0, here it is 0, here it is C1, here is 1. So I can write for M, powers of M, 0 equal to C1 plus 1. You take the value, C1 comes under C1 to minus 1. Okay. Similarly for L here once again right hand side 0. If you take the left hand side A1, here L power B1, A1 plus B1 plus minus 3C1, here plus 1. So here I have L A1, L B1, L minus 3C1, here L power 1. So A1 here, B1 here, L power B1, minus 3C1 here and plus 1 here. So you are equating this L power 0 to on the right hand side L power value. So I can write like this. Similarly go for powers of T. So if you rearrange this, already we know the value of C1, you can substitute the C1 value here and you can rearrange and you can find out you are getting 2. Okay. So I can write A1 equal to B1 plus 3C1 minus C1. Instead of C1 I can substitute minus 1. Okay. You get once you get the B1 value you can substitute here. So powers of T, T power 0, T power minus 1B and T power minus 2. Okay. So 0 equal to minus B1 and minus 2. So from this I can find out B1 equal to minus 2. Once you get C1 equal to minus 1 and B1 equal to minus 2, substitute to this value here bigger equation and you can find out what is the A1 value also. Through this equation I can find out what is my A1, B1 and C1. And you can substitute A1, B1, C1 value here. A1, B1, C1 value here. Once you find out this is what you have to find out. Once you understand only one, you can easily solve the remaining easily. Okay. So substituting the values of A1, B1, C1 in equation 4, you can find out that is phi 1 equal to L power minus 2. That is L power minus 2, V power minus 2 and rho power minus 1. Yeah, this is LB rho. So L power A1 is minus 2, L power minus 2, P power B1, so B1 is minus 2, and rho power minus 1, so rho power C1, so C1 is minus 1. I can write for the values here. Now all the terms you bring in numerator and denominator. 5n equal to R by L square B square and rho, R L square B square rho. From this you can find out which is comes under denominator or numerator, which is directly proportional or inversely proportional. Okay, so if you take this term here, R and L square will be the opposite side. It's not multiplication, this comes under division. So resistance depends upon this value. If you increase this value, resistance will increase. If you increase the velocity, resistance will increase. Increase the length, resistance will increase. Increase the velocity, density, resistance will increase. These are the inference I can find out in terms of square. Two inference I can find out. One is whether I can increase or decrease the value. Second, I can find out it's the square of its or cube of its. So here all comes under square of its value. So this inference I can get it for resistance. What is the relation of rho LV? This is the first inference I get. Similarly, go for the phi 2 term. Phi 2 term. So phi 2 term will be, so phi 2 term is, that is L, V, rho and viscosity. So M, rho, viscosity. So this is a phi 2 term. That is right hand phi 2, right hand side is ML0. Here L, V, rho and viscosity. L, V, rho as it is repeating variable. Now you have to change this A2, B2, C2. Previously it was A1, B1, C1. Now it is A2, B2, C2. So for viscosity, M, L power minus 1, T power minus 1. That is kg per meter second. Kg per meter square or Newton meter per second square. So kg per meter second, you can write, remember like this. Okay. Similarly, you equate the powers of MLT on both the sides. Okay. Here M is 0. Here M is only C2 and plus 1. You go with C2 plus 1. From here I can find out what is my C2 value is minus 1. Similarly, go with the powers of L. So L is 0 here and A1 here and B2 here and minus 3 C2 here and that minus 1 here. So A2, L power A2, L power B2, L power minus 3 C2, L power minus 1. So equate these two terms. So suddenly you cannot find out. So go with the T term. To T term, once again same. Here 0 here. So minus 1 B2 and minus 1. So minus B2 minus 1 you can write. From this I can find out what is my B2. Find what is my B2. So substitute C2 and B2 in the equation 2. I can find out what is my A2 also. Here I can find out what is my A2, B2 and C2. A2 is minus 1, B2 is minus 1, C2 is also minus 1. Now you substitute the value in the equation here. So we know the LV rho viscosity. LV rho viscosity. LV rho then viscosity. So A1, sorry, LA2 is minus 1. LA2 minus 1. LB2 minus 1 and density C2 minus 1 and viscosity. Here. So now you take the relation here. Take all the minus 1 that's out. So viscosity and LV rho. So that's the relation between academic viscosity and LV rho. Okay, the velocity increases, viscosity changes like this. Okay, it's not both are directly proportional. It is inversely proportional. Okay. This is the relation occurring with the phi 2 term. Similarly, go for phi 3 term. With the phi 3 term, so phi 3 remaining one is bulk modulus. This is a repeating variable. L power A3, write like this. P power A3 and density power A3 and bulk modulus. So bulk modulus Newton per meter square. Okay, if you know the Newton and meter square, you can write MLT power minus 2 divided by L square. So you get this equation. So as it is, one is geometry, flow, fluid property and your last term. Once again equate this term ML0 right hand side, left hand side. First go with the m. M is this side is m over 0. Always the 5 term should have this term only m. So 5 3 is a 5 1 5 3 5 3 are dimensionless term. So we will take m 0 l 0 t 0. So 0 equal to that is m. So c3 plus 1. Okay, m power 0. So m power c3 is c3 and this is plus 1. c3 plus 1. From here I can find out c3 equal to minus 1. Similarly, L is a3, here b3 minus 3 a3 and L power minus 1. So you can write. So we keep it as it is. Once you go for t is 0, t power minus 3, that is minus b3, here minus 2. So minus b3 minus 2, from where I can get p3 equal to minus 2. Once you got c3 and b3, substitute in the second equation, I can find out what is my a3 also. a3 here I am getting 0. See, a3 I am getting 0 here. A3 I am getting 0 here. Okay. So now we substitute the value once again here. So LB, L power here, LB over here, L power 0. That is a3 is a 0. B3 is a minus 2 and C3 is a minus 1 into K. Now we can write the equation, the L will go away. The bulk modulus, it is not affected by length. Bulk modulus is a relation having velocity and density, not directly related to the L goes to 0. So I can find out some relation between both the parameters of L, V, K like this. Okay. So once you find out phi 1, phi 2, phi 3, you go with the equation from first equation and write. So the first equation, initially we started like this. F of phi 1, phi 2, phi 3. F of phi 2, phi 1, phi 3 equals 0. Can write like this. Okay. So this is a dependent term. Take the dependent term on the one side and independent term on the other side. Take the dependent on one side. So R is a dependent term. Take it to the one side and keep the remaining terms on the other side, the independent term. Okay. So when you put an independent term, you can put a 5 constant like this. This means this may be a 2 times or 5 times or 10 times. Number of times not affecting much. Our finding out is whether it is a relation directly proportional, directly proportional. Okay. That's what here. So this is a dependent parameter R by rho L square V square into this independent parameters of viscosity and bulk modulus. Still you can reduce like this. Still I can write for R independent parameter rho L square V square into some constant term of 5. So this may be some value. So you can find out like this. So what is the inference from here? So if this value increases, your R increases. This value increases, your R increases. If this value increases, your R decreases. Okay, this is the denominator. What are the things that is comes in the denominator? Still you can reduce. Still you can multiply the term inside and still you can reduce. But you can find out some relation between these 6 parameters. So this is what you have to find out through all the dimension analysis. Okay. So I will repeat once again from here. So this problem is given. The problem is given. Resistance of force contains, from the problem you can understand you are having 6 parameters that is involved. So including this R is a dependent parameter. R is a dependent parameter. So these other 5 are independent parameters. Okay. So independent parameters are length, velocity, viscosity and density and bulk modulus. These are all independent parameters. Okay. So you have to find out what is the relation between dependent and independent parameters. That's what you are going to find out. Okay. So repeating, those who are not reading my lecture carefully, you go through once again what I am telling. Now we will have the understanding of how to choose repeating variable, how to write the 5 1 terms. So A1, A2, A3, L1, L2. So how to write like this, you will understand. Now once again we repeat once again, you will understand how to write. Okay. First you find out what is the write out first. What is the dependent variable? Write one side. And what is the independent variable? Write another side. Total I have 6 and 1 plus 5 is written like this. Second, you write the equation, which is take the dependent one side and write the independent on the other side. F of L, B, mu, Q and bulk modulus. Okay. This can be written as F1 of equal to 0. From this equation problem I can find out the number of variables is 6. Number of variables is 6. So from the Buckingham by theorem you can understand if there is n variables are there, the number of 5 terms should be n minus m. M will be a fundamental dimension always MLT, m will be always 3. So total you have 5 terms should be there. So the number of m equal to 3. So n minus m, 6 minus 3, you have 5 terms you have to find out. So before that you have to write dimensions for all the terms. This is very important. If you are not knowing any units of each term of fluid property, it is difficult to write here. Okay. So you know all your 6 property. Write the dimension for 6 properties. Very carefully you write. Resistance is force, mLt power minus 2. That is mass of the acceleration. So velocity is meter per second, Lt power minus 1. So viscosity is ml, L power minus 1, T power minus 1. Then density, kg per meter cube. And bulk modulus, m L power minus 1, T power minus 2. These are all, write carefully. So bulk modulus is Newton per meter square. Bulk Newton per meter square. So that is here you have Newton. Resistance is force Newton. Divide the value by meter square, L square will be this value. So I told normally you find out force, density and viscosity. These things don't forget. So if you understand these 3, you can solve another, derive any dimensions also. So number of 5 terms, how to find number of 5 terms? Will n minus m, total you have 3. So f of 5 1, 5 2, 5 3 you can write. So find out repeating variable. So you are choosing repeating variables. Normally you will choose LV row. In your problem it is available. So I am choosing LV row. So the repeating variables should contain geometry, flow and fluid. Select these 3 as a common term. So 1, 2, total you have 6 variable. 1, 2, 3. These 3 are repeated on all the 5 terms. And this is 4, 5, 6. So this is a repeating variable I have chosen. Write L1, A1, B1, C1, A2, B2, C2, A3, B3, C3. So this is what you have to arrange. Then take the first 5 times you solve. Always the 5 one is a dimensional system. Put M0, L0, T0 and write the units for this L0 and resistance R. So L length, L dimension is L, V. So Lt power minus 1. That is meter per second. And here density, kg per meter cube. M L power minus 3 and this is resistance, force mLt power minus 2. Okay, you can write like this. Then you equate the powers of m L0, L0 on both the sides. Here always 5 1 will be m0, L0. Here the right hand side m is 0. So here 3c1 and plus 1. You can write like this. Okay, then L0. So A1, B1 and C1. Here plus 1. Since the term is length here, you cannot find out. So go with the T. T is 0, minus B1 and minus 2. So from here I can find out B1. Substitute the C1 and B1 the equation 2 and you can find out what is the A1. Here A1 is minus 2, B1 is minus 2, C1 is minus 1. Substitute this value here. Directly into the LV row. Instead of dimension, go with the, we know what is the LV row. So directly L power A1 minus 2. B power minus 2, B1 minus 2, rho power C1 minus 1 and R. Write R as it is. Okay, you can write a relation like this. So R by, so now you can find out what is the relation between resistance and these parameters. Okay, similarly go with the phi 2. Phi 2 also similarly writing ML0, T0, write all A2, B2, C2 and second term viscosity, that is Newton second per meter square or kg per meter second. So kg per meter second, you can write like this. So remember like this. So equating the power on both the sides, I can find out Ct equal to minus 1, B2 equal to minus 1 and A2 equal to minus 1. write directly in the equation LV rho. LV rho into viscosity, I can find the relation between viscosity and the LV rho relation. Similarly, 5-3 terms. So L3 V3 V3 into bulk modulus, and write down second powers of the equation. Find out C1, C2, C3. Here I am getting A3 as 0. That is, my L term is not equated to 0. So I can write L power 0, and I can write the relation K depends upon this V square and rho. So L is an order inclusion factor for K. So you can find out. So once you find out all the 5 1, 5 2, 5 3, write your term. F1 equal to 5 1, 5 2, 5 3 equal to 0, or take the dependent on one side and independent on the other side. So dependent here resistance, independent on all these parameters. So I can write like this. Still I can write R equal to rho L square V square 5 mu K V square rho like this. These are all the parameters shows. Now you can find out dimensions on both the sides are matching, and also what is the relation, is it dependent or independent, or this numerator or denominator, which one has to be increased, it will be changing, what parameters if increase it will change, like this you can find out. For all the equations what you are framing through any research, you have to solve only through this method only. It is what you have to find out. Okay, so it is very easily you can solve. Even the 6 parameters you can easily solve. Through Rayleigh's method, it is really difficult to solve like this. For all the parameters, even if you have n number of parameters, you can easily solve the relation between each parameters. So through Buckingham pi theorem, I can solve the dimensionless analysis easily than the Rayleigh's method. So I hope you have understood all our what I solved yesterday. If you have any doubts, you go in the previous video what I shared to you in the YouTube. So I will show the descriptions also. So if you see the previous video, then go to the problem. Go decide. Don't see directly this problem. See my previous explanation, then go to this problem. You will understand. Okay. So thank you, students.